we are going to record this. So if you have any concerns about that or things you don't want to have go into the recording, just be mindful that a recording will happen. Okay, that being said, I did introduce myself. Usually when we do stand-ups, the person who is talking is calling out the next person to go ahead and introduce himself. So I will call out Ronan.
Hey there, I'm Ronan. I'm part of the Fermyon team, and just been interested in the WebAssembly space for probably about a year and a half or so, and a variety of open source projects. And nice to meet everyone. Let's see, Nigel, do you want to say hi? No pressure if you don't want to. Hey.
I'm okay. Yep, I'll say hi. So I'm Nigel. Hey. So I write books and I make video training courses about what I think at least are cool technologies, containers, Kubernetes, stuff like that. And yeah, I think WebAssembly is really cool. I'm going to say this right. I'm not a developer. So I have in communities like this and at Wasm Day and stuff, I feel like super out of my depth all the time. So I'm making myself a little bit vulnerable there. Like a lot of the content at these things goes way over my head. But I keep working hard at it, and eventually I get it, and then hopefully I pass it on to other people. So that's me. Who else have we got? Can I pass it on to It's Aryan?
Definitely. Hi, everybody. This is Aryan from India. So, first of all, kudos to the Fermyon team for doing a really good job and taking WebAssembly too far and doing a really good job. I've been following you guys from my outreachy contribution time period. I got to know about WebAssembly and its application and its work from you guys first of all, and I have been posting about these things on Wasm Builders as well. So I was working with the Inox project, which is the part of Confidential Computing Consortium, and yeah, really looking forward to talk to you guys and learn from you all. I would like to pass this to Kate G, if I'm pronouncing her name correct.
That's great. Thank you. Hi, everyone. My name's Kate. I'm also with the Fermyon folks, working on Spin and some of our cloud efforts there. Love this space. I think, like Nigel mentioned, there's a lot to absorb, which is what's really exciting about it and all the different ways it's being used, such as in ARCs. With that being said, I'll pass it off to Orpamipo.
Yeah, very nice stuff here. So my name is Opemipo, and I'm DevRel at Fermyon. I do DevRel, working with Mikhail, and mostly what I do is Bartholomew, trying to make the product I think pretty much more accessible, and trying to write a couple of articles, build use cases, get feedbacks from the community, just about Bartholomew. Really interested in making the platform pretty much more better, and also not just Bartholomew, Fermyon Cloud also really interested in it. And yeah, I guess I'll pass it to I don't know what else is here. I'm not sure. I don't have an idea.
We can let's try. Yeah, let's try. I was about to say Joel. So yeah, Joel.
And I don't know if it's Linux, but I can't see anyone else's camera. I think no matter what browser I use, maybe you can see mine here in a sec here, but I can't see you. Oh, I can see myself. That's good enough. Yeah,
I still cannot see you, but that's fine.
Oh, all right. Well, I can see myself, and that's what's important here. Yeah, I'm a developer at Fermyon. Been here for about 5 or 6 months now. Mostly working on spin-related things, if not spin itself. Things like Wasm time and WhipBindGen and things that make the component model work. If you're familiar with the term component model, it's part of a big part of how spin works and allows you to interface with the host functionality like networking and so on. And yeah, I think that's about all I have. Let's see, who else is here? Kenzie, you want to go?
Hey everyone, my name is Kenzie. I am a new addition to the Fermyon team. I'm working as a product manager specifically on the cloud. I'm really excited about the WebAssembly space and happy to be here and chat with you today. I will hand it off to MK Craft.
Hello, everyone. Hi, I'm Melissa Klein. I am new to the Fermyon team. So I am in the process of learning all of the things, and I am so excited to join the first community call. So let's see, can I pass it off to Serial Byte?
Hi, everybody. I'm Brian, Serial Byte. I got many internet names. I'm a Fermyon engineer, work on Spin, and general WebAssembly ecosystem projects, participating in the component model as well. Nice to meet everybody here. I'll pass to Karthik. Do you want to go?
Yes, so I'm Karthik. I'm an intern at Fermyon, and I work on language for now, along with contributing to Wasm. Can I pass it to Shantan Desai?
Yeah, hello everybody. This is Sean. I'm originally from Germany. At least currently I am based in Germany at this point of time. And you might call me as a technology drifter. You'll find me in a lot of Slack communities as well as a couple of Discord communities. And I'm actually from the industrial IoT space. Looking forward to being one of the person who probably might be able to help you out with Wasm on the edge, especially in the industrial space. And I'm happy to learn and get to know a lot of people here at Fermyon. So thanks for having me. I'm sorry, I'll pass it on to maybe Radu.
Hi everyone, I'm Radu. I also work at Fermyon. I work on Spin and Fermyon Cloud and all the things we're doing. Really great to meet everyone. Hope you will have a great community meeting. Going to BRK21.
Hey everyone, my name's Ross. I am a data science consultant. I heard about Fermyon through the Python podcast. I've done a lot of work with different serverless architectures for data pipelines. And so just interested in the work you're doing with WebAssembly and how that can serve as sort of the next generation of architectures for the data pipelines that we've built using, Lambda, Cloud Functions, things like that. So excited to be here, still learning about WebAssembly. It's still very new to me, but nice to meet you all.
I think that's it, Bill, along the people who either had mics or were around. So is there anyone else who wants to say hi before we pass it back to Mikkel?
I'll take that as you passed it on to me. Cool, thanks, Otto. Okay, so as most of you probably know, 3 weeks back we launched the Fermyon Cloud at KubeCon. So we think this is it's been a very exciting moment for us getting to that point where we can take the concept of the Spin application model and Spin applications and now have a very easy way to go and host these inside the cloud. So I'm just going to run through a few of those, just easy getting up and started and a few use cases that we've been playing around with and hopefully inspire you all to do a little bit more with the cloud or even try it out if you haven't so far. So let me start sharing my screen. And you guys see my screen now? I myself do not see my screen being shared.
Not yet.
Again. Okay. Go live. Go live. I'm live. Are we good? Okay. Let me see if we can get things going. Okay. So, as part of releasing the cloud, we also released a new version of Spin 0.6. And part of what we did in that new version of Spin is we introduced a nice new Spin New experience. So once you run Spin and you want to create new Spin applications, we have a list of templates that we provide. Some of these come
a little bit, Mikkel. Sorry.
Sure. Let me do this, and is it better?
That's better. That's better. Yeah, thanks.
Okay. So we have this list of templates that come pre-packaged with Spin. So basically, an easy way for you to, pick a programming language you want to use either HTTP or Redis triggers. The C# template that I have in here is sort of experimental, a little bit off the chart. So you need to go and add that template yourself. But obviously, there is an easy command for that in Spin where you can basically say you want to install a template. And in this case, I'm going to install it from a Git repository. And I can choose to potentially update it if that's what I wanted to do. So tagging onto this new, Spin, let me find Spin experience. Let's just try and create a simple HTTP Rust application. Just see how this works. So let's do Rust HTTP. And if I switch over to Visual Studio Code, I'm gonna do a little bit zoom here. Is this enough zoom? You can see how. Okay, you can see how the template is giving you the spin.toml file, which is really the description of a Spin application. There's some metadata about a version, what type of trigger that the application is using, and then there's a list of components. And in this case, we're setting up a Rust component. There is a build command. And then obviously there's the source, which is the output of the build command that will eventually be loaded once we run a spin up command. What we also have in these templates is we just have scaffolded out some very easy code. And what you can see in here is that we're going to get a request in, and we're basically just going to send a response back saying, hello, Fermyon. So if you very quickly try this out, we will run our spin build. We'll first go into our directory, the Rust directory. And then we can do our spin build command, which will then go and run the build command that you saw in the spin.toml file. And once that is over, we can do the spin up, which is now started serving our WebAssembly module. So we have this WebAssembly module on a local host. I can go over, I have another window. You can just zoom, and we can go and curl that, and you can see our WebAssembly module is replying. So that's all good, and that is very simple. That is really all you need to get started. Now, the next step, if I want to go and deploy this application into a cloud, I need to do a login. And Spin login defaults you to the Fermyon Cloud. There are options for you to run your own infrastructure to host the applications. So you could do a login against a different endpoint than the cloud. And you'll basically pass in a URL parameter to the Spin login command. But here I'm just authorizing against the cloud. With my device, and all I have to do now is do spin deploy, and we'll make sure we package up the built WebAssembly module you have, the Wasm file, and taking the spin.toml file as well, or any other static assets that you need, and those would then be declared in the spin.toml file. We package them up, we deploy them into the cloud, and create the application for you. Let me go over and find a browser window. And I can then, this is the fancy new browser that Rado is trying to make me use, and I'm a little bit confused with this browser sometimes, so please bear over with me. But if we go to cloud.fermyon.com, you can actually see our application is already created here. And we have an endpoint, we will have logs. So if I go and open this endpoint, we can see the Rust application is replying, hello, Fermyon. And we can also see the logs that are being emitted from the WebAssembly module down here. We could potentially download the logs if we want to, or search through them. And that is really the full cycle of, what we call blinking cursor to deployed application in less than 2 minutes. I don't think I made it in 2 minutes. Maybe I was talking too much as I went along. But we have actually timed it, and you are able to do this in less than 2 minutes. Okay. So that was the simple case. We have a few applications that, or fun use cases that we've been doing here to just showcase some of the stuff you can do with these Spin applications today. The first one is this click application up here. This again is written in Rust and it's an HTTP application. But what I wanted to show here is how we have support in our Spin SDK for interacting with Redis. So for Spin, we have SDK currently in 3 different languages. We have in Rust, we have in Go, and we have in C#.NET. C#.NET is still somewhat experimental, and especially around cloud support, there are some things that you cannot do today. But here in the REST SDK, for instance, we have support for interacting with Redis. Some of you who work with WebAssembly and in Wasm in particular know that there is no support for doing TCP connectivity from within a WebAssembly module today. But what we've done with the Spin application model is we made a way through the SDK to proxy calls, because we take your request and proxy them to our Spin executable using something that is a little bit like a component model, but not quite the component model yet. And in that way, we can actually open up for the opportunity to talk to a database and persist data. So even though we don't have those data services in our cloud, you can target a Redis instance. And in this case, I've just created a Redis database over on Redis Labs, which, by the way, is an awesome service for anything Redis. You get a Redis database in like 5 seconds, almost as quick as deploying an app to Fermyon Cloud, I guess. And then you can play around with that. So in this application, what I'm doing is, if we have a post request coming in, we basically go and increment the key called clicks, and then after that we'll just go and read how many clicks we have, and we'll post that back. So if I go over to that application now, and again, I can do a spin up locally on any of these applications, and this is just you can see how quick it's actually starting up here. And we can go ahead and we can curl again to this API, and we can see that we have 39 clicks in our Redis. Now, if you went ahead and post to this, and we have to post to the API, we now have 40 clicks. Okay, that's all good. That's a nice kind of API to have, but if we really want people to actually click, we probably needed a front end instead. So some of the stuff you can do in the Spin application model is that we can have multiple components sit on different routes that we listen to. So again, you can see the structure of the Spin application, that we are still with HTTP triggers, but I now have 2 different components in here. The click component I showed you is basically just a backend API, whatever you want to call it, and I mapped it to a route called /API. So what you probably noticed over here, that when I posted and when I ran a get, I targeted the API route for that. But what I have en route here is a static file server that we created. So basically, I've just copied this Wasm module from our static file server repo, and basically what it does is that it maps a given source directory as a file server on the URL path. So what I can do with this is I can actually create a static front end with an API backend. So basically, my static front end is my index.html page, which just has a button that calls the API. So if I go back to my application now, and I'll just go and zoom in a little bit, find the right thing here, and I go to my index.html, we now have a button. And again, this is also served by Spin, right? This is just static file contents that are being served by Spin. And now if we go and click this, we can see how this guy is incrementing. And for some reason, I didn't find out why it's incrementing in 2s. I don't know exactly what's happening here, but it is actually incrementing. So you can see how we now have, off by 1 errors. But it's a consistent off by 1 error, I guess. So you can see how very quickly you can do these things with static front ends and backend APIs, and even this is all the way going to Redis and storing data and persisting them there. So this is all good, and this is all the local experience I've been showing you here. Again, I could just run a Spin deploy, and we'll go ahead and deploy this into the cloud. I did that up front. it doesn't take a long time. So it's not because we couldn't do it. I just already have it deployed. So if you guys want to play along, you can go to, this is an awesome URL, but click dash, let me put that in the chat. It'll probably be easier. There you go. Oh, and you have to add index.html yourself. We have not fixed that yet. And we can see how many clicks we can get. So as everybody is clicking by, we can see how this should be counting up. And again, this is just static content being served up the cloud. We have that API backend. It talks to Redis over in Redis Labs. Data is persisted, and all of this just works beautifully with the cloud. Okay, so that was one fun use case with data stored. The last one I want to show is a thing that sort of took a little bit off this Friday, last Friday at Fermyon, when we started creating Slack bots, because Slack bots are pretty awesome use case for Spin applications. And the reason why is because the way that Spin, the execution model in Spin works is that your WebAssembly module doesn't run. It's only, oh, we got to 1,000. Thank you, Rob. The module itself is only being run as a request comes in, and we can do that because these modules have, the sub-millisecond startup time. So there's something you have to think about in terms of how you sort of architect your application, in that each request is actually, there's no such thing as sessions or state. State, if you have that, have to live somewhere else. So, which also means that from a resource usage, it's only when there is a request coming in or something triggering the module that resource is actually being used. Which is why a use case like a Slack bot that someone calls, occasionally, will almost respond instantaneously, but it's actually a cold start. I just want to show you how simple these things are, and to just spread things out a little bit. I did a small bot in .NET. So basically, again, we have a Fermyon SDK for .NET, and it's the same pattern that you saw on the Rust HTTP triggers, that we hand off an HTTP request to your code, and you start doing what you're doing. And basically what the bot is trying to do is it's picking up the username for whoever invoked the bot and say, hey, hello, this is your friendly .NET bot, and basically just sending that back. And so you can see I have 20 lines of code here. I have a little bit of structure and stuff down here as well that I'm dealing with, but that is all I have to do to create my little Slack bot. I have also deployed this to the cloud already. And if I go over here in Slack, in my own little private demo room, so no one is missing what was going on, I have a little bit more control over my my demo. And I go to that, and again, remember, as I hit enter now, the request is leaving Slack, and it goes to the Fermyon Cloud, and the Wasm module is being loaded, and that C# code is being run, and the request is being returned. And I mean, to me, this is some of the most amazing things that we can do with this model. It's just like the speed at which we can execute these. And Fermyon Cloud is free today, right? But let's say we went into a model where we would build you on resources. Like, it was just the number of resources that request used that would actually be sort of the billable unit. And now the Wasm module isn't running, so no resources are being used until someone calls that bot again a different time. I think we have a Friday bot as well that we can try and call. And you can see how all these things are just replying to us. It's not Friday. Oh, but Redis said hi, by the way. I think we have grapes we can increment as well. We have a lot of these bots by now. So yeah, again, this is
becoming a problem. Yeah.
The grapes is becoming a problem. The bots are becoming a problem. Yeah, as long as we don't get a bot war at any point in time. But I think the main thing about this is that it sort of hits one of these use cases of the infrequent execution, and that this module is just there and it's not using resources until it's actually being called and someone wants to interact with the bot. So I hope that gave you some ideas about what other stuff you can do, whether you want to work with state, whether you just want to build a small bot for your Slack channels or Discord for that matter. Try use that with the cloud. It's really simple, and it's I've spoken to more people who saying the same as I myself had that feeling that it's quite fun developing with this, because there are no big things to deal with. It's smooth, it's small pieces of code, and it's just fast. So that was a little tour of where we are with Spin and some of the Fermyon Cloud and what we find fun with the Fermyon Cloud. Well, you never get cold starts. Well, you always get cold starts, but they're really fast, right? So yeah, to Router's point.
Yep.
Cool. So I guess at this time in these calls, typically we just open up the floor for any question anyone wants to bring, whether that's a question about Spin, a question about Wasm in general, Fermyon Cloud, anything you guys want to chat about. Either just come off mute and ask the question, or feel free to use the chat. The electric car version of cold start. Yeah, instant. What do you say? Instant talk? Is that how you? No, that's what. Is that what you? No, it's not instant. Is it? I don't know if that's the right way of using those terms. But yeah.
Hi, Mikkel. This is Sean again. Do you mind if I ask a question here?
Yeah, sure.
So in general, why is there such a high need for, let's call it, isolation in terms of things running on the cloud? Like we started off with virtual machines, then ended up into containers, then went to unikernels, and then now we'll end up in a very secure sandbox like Wasm. So what's particularly driving such kind of isolated needs, or such kind of let's call it function as a service things currently that in the whole cloud landscape? Is there a particular reason behind these kind of requirements that are currently going on?
I mean, I can give you my take on what this is and what's driving these things. And I think anyone else should feel free to comment. But I think there are a few different things. So one of the movements that I know that we have been that we are talking about is talk a little bit about this next wave of, well, not a little bit. We talk a lot about the next wave of cloud computing. We see WebAssembly have a space there. And if you see that as a continuum of the movement from physical servers to virtual servers to containers and now WebAssembly, I think it's all a matter of getting to the smallest possible granularity of the thing that you can easily and dynamically move around to really optimize for resource usage of the physical hardware that you eventually need to run any of these things, right? So with virtual machines, it became easier to, you didn't have to physically move a server if you needed to migrate from one data center to another, or from one rack to another because of, upgrades of power or whatever. And with containers, we could do that, even quicker between virtual machines. And what we think with WebAssembly is that the unit of deployment that we now move around is so small so that it just increases the opportunities for running compute far more efficiently. I think that's actually the main thing of this whole movement. And it has some effects as well on the developer experience, which I think is one of the things that I was trying to showcase here, is that imagine some of the stuff I had to do with containers, and just creating something new. If I haven't pulled a container image to build in, I had to pull that container image down, which means there's a lot of file that needs to be moved. As well as I was deploying, either if there was a build service somewhere, the code had to be matched with the container image at some point to run somewhere. And with WebAssembly, it's just far less data we have to move around, and it just makes that a lot better. I think on the security side, which I think you also, at least when you said isolation, it sort of thought my mind in that direction. I don't think knowing that you've been working around, sort of the concepts of continuous compute and enclaves and stuff like that, I don't think WebAssembly as such changes it at that layer. I mean, whether you run WebAssemblies in a continuous compute boundary and enclave or whatever, or you do that with a container, again, I think the main thing there is it's smaller pieces of data that we have to move around in order to be able to do that. Then WebAssembly as such is more secure than containers. I don't know. Anyone, others feel free to chime in. But yeah.
The only thing I'd add there is that by default, your WebAssembly module will get no access to any host APIs without explicitly being granted access to those APIs, or files, or other parts of memory other than the linear memory allocated to it. So in short, it's basically a new way of both a deployment unit and execution unit that is both smaller and faster to start compared to the previous iterations. So it helps in workload density and making sure that you can run heterogeneous workloads on similar infrastructure on the same nodes without getting into any sort of noisy neighbor problems or other people being able to access by default memory or other things on the host. So it's an on one hand an iteration over the execution and deployment units that we've seen so far with the containers and then VMs, and on the other just switches the problem of deploying an application from packaging an entire virtual machine operating system or file system to you just get your compiled bytes of your application over the wire, and those will start in a sandbox.
Any other questions? If not, maybe do you mind if I chime in again? Yeah. So one thing that I'm quite curious about is if the Wasm modules are pretty small, is there, so to say, a future where people can actually even send Wasm modules as a part of a request, like trigger on the fly or something like that?
I think I can perhaps partly answer Nigel's question in chat. I think part of the expectation with the component model is that you would be able to create essentially virtualizers or adapters for what you might call legacy apps that expect to be running on, say, a Unix-style environment and deal with sockets and file handles and that sort of thing. At maybe a lower level than the component model would otherwise encourage you to work at. And the idea is that we want to make the migration from kind of the older model to a more component model as easy as possible, and part of that would involve creating essentially virtualized shims that essentially make the environment which you're programming look like it's a more traditional socket and file handle based environment, but actually gets adapted to a kind of a higher level API. So I don't know if that helps at all.
Going back to the previous question about being able to just send WebAssembly payloads with a request, technically yes, and that's interestingly enough one of the things we played around with a long time ago, a few years ago now, of being able to just, as the client, send the WebAssembly module to a server, being able to run it and just execute it there and get a result back. That's something that's technically possible in the future with the component model. It's still not yet there. Mainly, what you'll need the server side to be able to do is to execute a previously unknown or unseen API dynamically and then return your result. That's something that we're optimistic about in the future. But that's a really exciting use case. I very much agree with that.
And I think on the IoT side that you come from, Sean, that's particularly interesting, especially if you think about over-the-air updates that you could potentially do in the future with WebAssembly. or just like remote control of IoT devices with WebAssembly. So I think makes sense that that's an exciting question for how you can make kind of a more dynamic life cycle for those more constrained IoT devices.
Yeah, I mean, it pretty much sums it up, like what Kate was like mentioning at this point, right? Like, generally, the case is we, from the industrial side, we have devices that generally come pre-programmed, and something when it goes haywire really, really badly, then it's all about physical contact with that OT, like the operations technology and everything. So, if Wasm is supposed to be, let's call it a game changer, then probably I'm betting my money on the industrial side too. That if something like this actually ever happens, then it's quite interesting to see if that actually occurs on the OT side too. So yeah.
There's been a lot of interest, particularly for that use case, right? Being able to have over-the-air updates to stuff that's running on IoT devices and dynamically update stuff without writing firmware. And there are a lot of scenarios that are really, really interesting there. Last point on the question Nigel had and the answer that Joel gave there. Yeah, I think Joel was spot on in which the virtualization part of the component model would enable older or non-component model code to be able to run inside newer runtimes. But there's also going to be a lot of WebAssembly and containers running side by side. There are a lot of scenarios where you still need to run containers. For a lot of scenarios, stateful, long-running stuff, at least for now, will most likely be running in containers. But the types of applications that you currently run in containers that are always running, that are replicated across multiple instances, that are just stateless web servers for each single microservice, those are really good candidates to just extract out of needing to run a number of containers all the time and just move them to a model where you just instantiate them just in time and only execute it for milliseconds as you need to handle requests and then shut everything down. So it's just another way of using the right tool for the job. And I think we'll see a lot of scenarios where we'll just use WebAssembly microservices for short-lived, bursty workloads and continue to use containers for stateful, longer-lived scenarios.
And I just want to, if anyone, or if someone didn't see it, like Docker did release a technical preview where they actually in Docker Desktop have support for WebAssembly now. And I think in one of the demos they show how in the Docker Compose file you actually run a container and the WebAssembly module side by side. Like the one demo that I showed where we needed a Redis database. In most scenarios you would have a Redis database in a container locally. So yeah.
Yeah, and Nigel wrote a blog post about that.
There you go. And another use case down those, or another feature that sort of showed up down the road is how AKS in Azure also supports spin applications as part of the cluster. So you could have a Kubernetes cluster that can run both spin applications and containers. In various configurations. Again, this is also very early days of seeing that, but I believe that's definitely one of the first movements to broader adoption, that some use cases find their way into WebAssembly while a lot of things are still running in containers, and probably will continue to do that for a while. So yeah.
Yeah, I just shared the documentation for the Azure Kubernetes service where you can just configure your Kubernetes cluster to run spin applications. So if you're interested in that, have a look at that. It's really cool.
Yeah. Sorry once again, guys. I'm a bit too curious at this point of time. But are there overlaps between Wasm and what the eBPF guys are doing currently at CNCF? I mean, so as far as I understand, I do work with kernels, but our kernel applications are quite different because you have to work on hardware levels. And what I understand from Liz Rice and the people that are pretty much big in the eBPF communities, it's more or less like a sandbox that you tell the kernel to trigger, and then it gives you a lot of like information back at the kernel level, which you don't have to go through a lot of processing. Maybe let's call it quote unquote cheap. So is there some form of overlap that you guys see, at least in terms of Wasm and eBPF?
I will preface my answer by saying that I know very little about eBPF and how it's used in practice today. The one thing that I will point out is that eBPF and WebAssembly, the WebAssembly sandbox, take different approaches to sandboxing, right? WebAssembly takes the deny all by default stance, where you literally don't have access to any host or kernel APIs at all. You have to go through the host and specifically enable any specific API that you want to give your guest code access to, which is how we run HTTP, outbound HTTP requests in Spin and connect to Redis and other things. Whereas in eBPF, you would have to it's enable all by default in the kernel, and then you disallow access to specific kernel operations and kernel APIs. So the overlap in sandbox might be there, but I think it's used for slightly different use cases in the end. And I'll let people who are more familiar with eBPF expand on that, if there are.
Hey, so I have a question. Can I?
Sure.
So, as I mentioned, I'm a newbie to WebAssembly and I'm still learning Rust. So if somebody wants to contribute to Fermyon products, different like Spin and other things, so what are the prerequisites one should follow?
Can I take that one, Mikkel?
Sure, yeah, go ahead.
Spin is entirely open source, and as you mentioned, yeah, it's written in Rust, so you need a bit of knowledge in Rust to contribute code to Spin specifically. We also have the Spin SDKs for Go and C# and Rust and a few others coming really shortly. So that might be a really good place for people to contribute in general. The one thing I will mention is that contributions to open source projects are far more than just code. There are a ton of opportunities to contribute to not just Fermyon projects, but in general in open source that is not just code. So documentation and help with the triaging issues and help with documentation websites and a whole lot of things. So if you're interested in contributing and interested in being more involved in open source projects, we're more than happy to help and guide you here in Discord or over in GitHub. Even if you don't have, for example, a Rust experience, there are a lot more opportunities for people to contribute. We also have a lot of good. We also have a lot of good first issues in both Spin and Bartholomew and a few other projects as well. So that those might also be a good thing to look at.
And I generally read your newsletters. I have subscribed them. The technical writer that write the blogs is awesome. He has a very good taste in writing things. I don't know who is the man, but I really followed. I learned a lot from technical writing from that thing. So kudos. Thank you.
I appreciate the feedback. Thank you.
We will definitely pass it on to Tim, who's our main writer there.
Who's for some reason asleep at like 5 a.m.
Well, he's actually on vacation, so he may or may not be asleep, depending on where he is. We have this thing, I don't know, if you get into our cloud dashboard, you will see there is a small footer saying that the cloud was built across, what is it? Is it 5 continents and 9 time zones? That is actually true for the Fermyon team today, is that we are really spread. So yeah.
Might get a 10th time zone soon. Fingers crossed.
Yeah. I don't know if that's good or bad, but we have to deal with it. I added a few links there in the chat. One is the contribution guide to Spin. The other one is basically a query on the open issues we have in Spin that has this good first issue label. That's always a good place to look. But if you go into the Fermyon org on GitHub, as Router says, we have a few other projects in there that we are happy to take contributions to as well. Both SDKs, like the static file server is a small project. Bartholomew is this CMS thing we build and run our websites on. So there are definitely a lot of different places you can go and look.
Hi guys, I'm back again. Seems like this is going to be a bit more questions from my side, but just curious whether do you think that that Spin goes beyond the whole HTTP paradigm at this point of time? Are there other so to say models that you have in your roadmap? Is it always request response, or would it be PubSub or maybe something else?
We do have PubSub with Redis today, at least for Rust and Go. Just don't support it in the cloud yet, but you can do a bit of Spin application.
And just expanding on that a bit, as Mikkel mentioned, in Fermyon Cloud currently you can only run HTTP applications, but Spin supports PubSub with Redis today, so you can connect to a Redis PubSub channels and instantiate WebAssembly modules for new messages on a given channel. And the way we're using the WebAssembly component model gives us a fairly straightforward way of defining new application models. So we are actively looking at other types of triggers and other types of mechanism to instantiate and execute WebAssembly modules given different types of events. I think it's the way Spin is currently built is really it's a good fit for sort of event-driven models and event-driven applications. So any sort of trigger there might be a good fit. And if you're interested in collaborating, contributing triggers, we'd be more than happy to show how to write a very simple one. And I think there's an example over in the Spin documentation of extending and embedding Spin. Describes how to do that. So you can actually do it yourself if you want to get your hands dirty a little bit.
Can I ask how many on this call have tried the Spin? Like just do a thumbs up or something like that. Oh, there's even fire and fermions and things going on. Okay, cool. And how many have then tried the cloud? This is like a totally unstatistical way. Oh, we have rocket ships and. Okay, cool. Quite a bit. That's nice. I don't count the Fermyon people, by the way, because well, grapes. Grapes.
Please give us feedback on both the getting started experience with Spin and Fermyon Cloud and the deployment experience and all the moving parts there. Fermyon Cloud is a very, very young service. It's officially 3 and a bit weeks old. So any feedback there would be really, really appreciated.
And the easy way to give feedback is either the channel here in Discord, Cloud, Spin, whatever, we are monitoring those. Kenzie was so kind to just throw in a survey if you want to give feedback on trying the cloud. And again, yeah, feedback on these community meetings, feel free to use the chat in here as well. And I think we have a few repos. I think we have a feedback repo as well, actually. So we are all about channels for feedback.
Yeah, any sort of feature request you wanna file, you can either file it here in Discord, or we can talk about it, or if you wanna put it in the feedback repo, that will also be excellent. It will give us a good chance to track that. Oh yeah, and bug reports, but you know.
As in there aren't any. Well, before they can find a bug, they have to use it, right? So If you don't see any bugs, it's not because you wrote perfect code. It's just because no one is using it. And so the few demo apps I show, I'll make sure to put them in a repo. I'll come back to this general channel and just post a link so you can find that code and have fun with bots and clicks and other things. So we are coming up towards the end of the hour. I hope you guys found this useful. We keep having these community meetings every month. We sort of alternate between times so that next month we will have one that is, depending on where in the world you are, either earlier or later. I don't know how to say that, but it's just a different time. So it's more convenient for people in other parts of the world than this time, which means that in January we'll be back at the same time as this community meeting. But again, we're always available on Discord. It's a good place to find us. So feel free to reach out, and if you just want to chat, have a random question, if you want to like spend half an hour with some of us, if you're trying to build an application, you have some issues, you need some help, you want some pairing with developing whatever, just reach out. We will really love to do some interactions with you guys in terms of what it is that you want to try and accomplish with Spin on the cloud.
Definitely. Thank you so much.
And thanks for bringing all the questions today. If nothing else, we'll hopefully see you next time.
Thanks everyone.
Thanks everyone.
Peace. Bye.